We shall take up an interesting topic today, and the topic is studies on chemical kinetics. Here, today we shall take up 2 points. We shall learn what is meant by integrated rate law, and also we shall have an idea about first order reaction. Its salient points we have to learn. And here is what is meant by integrated rate law. We find that we can calculate, we need to calculate, we need to know the concentration of the reactant at a particular instant of time, and this gives us the instantaneous rate of reaction. We have already learned about what is meant by average rate of reaction and the instantaneous rate of reaction. Instantaneous rate of reaction is the change in concentration at a particular instant or moment of time. And when we consider the reactant plotted against time, we find a curve which is convex in nature, and at a particular instant of time, we can calculate dx by dt by getting a slope, tangential slope at the particular instant. Similarly, if you consider product, concentration of the product, we get a slope that determines about the rate of a reaction, instantaneous rate of a reaction at a particular instant or moment of time. But then this method is attended with inaccuracies and complexities. We need to evolve a simple method which can be more accurate and easy for us, and very good to understand that it is the mathematical relation between differential calculus and the integration which helps us to evolve a rate law which correlates concentration of the reactants and time. Concentration of the reactant at a particular unit of time is given by integrated rate law. And this also determines the product present after a particular instant of time, or this helps us to estimate the time required for reaction to proceed to a certain extent. Now, the integrated rate equation for different reaction orders. रिएक्शन ऑर्डर फर्स्ट ऑर्डर है, सेकंड ऑर्डर है, जीरो ऑर्डर है, किस प्रकार का रिएक्शन है इस पर डिपेंडेंट होता है. ये इंटीग्रेटेड रेट इक्वेशन हर एक का अलग अलग होता है. अब अभी आज हम बात करेंगे फर्स्ट ऑर्डर रिएक्शन के बारे में, फर्स्ट ऑर्डर केमिकल रिएक्शन. और इसका इंटीग्रेटेड रेट इक्वेशन अगर हमें निकालना है तो हमको पहले तो रेट इक्वेशन लिखना पड़ेगा. दैट रेट इज इक्वल टू के multiplied by the concentration term of the reactant, and this reactant can be represented as A within square brackets, that is in moles per liter. But even then, you find that in certain books, instead of AR, especially our CBSE book, instead of A, they have represented it as R, which is also very accurate and correct. A clear concept about the reactant is represented by R. But in most of the books, you find that rate is equal to K multiplied by A concentration in moles per liter, and that represents the concentration of the reactant. Now, the power to which A is raised here in first order reaction is unity, or 1. Of course, we don't write 1 over here, and that represents the first order reaction. Now, this equation, the rate equation, can be integrated rate equation for the first order reaction can be represented in terms of exponential power. That A concentration at a particular instant of time is equal to initial concentration, that is A naught, multiplied by exponential power of minus kt, where t is the time and k is the rate constant. Now, accordingly, a simple mathematical simplifications lead us to 3 different expressions as represented here. Mind it, ln. ln represents exponential logarithm. ln multiplied by at upon a naught. Of course, the concentration is equal to minus kt. Or you can simplify it further and get an equation that k is equal to 1 upon t in exponential logarithm multiplied by concentration of A naught initial concentration divided by concentration at time t. And this can be represented showing a linear dependence on concentration with respect to time. And ln AT is equal to ln A naught minus KT. But on these cases, we have used the exponential logarithm. Now, the exponential logarithm brings accuracy. Of course, I don't mean that the log to the base 10 is inaccurate. That is also mathematically correct, and accordingly, the first order rate equation can also be written as k is equal to 2.303 by t log A naught upon AT. A naught means the initial concentration and AT means the concentration at time t. Or many times practically we find it is written as 2.303 upon t log A small letter a, not divided by A minus X concentration time t at time t. Now here, this simply represents that how much has been consumed. Concentration at time t is equal to A minus X. X represents concentration of the reactant which has been used up or consumed at time t. So that's there. Now, these three different forms to the base of exponential logarithm, to the base 10, and this form, the practical form, are useful for us for many different calculations, different type of calculation depending upon the type of the question. And we need to take it up carefully and use all these expressions wherever there be a need. Now, one point to be very important is noted and should be noted, and that is the unit for the first order rate constant is time inverse. For example, it may be a second inverse, it may be minute inverse, or it may be days or hours inverse also, depending upon the type of the reaction and nature of the reaction. Now again, there is a linear format for the integrated rate law. And as we have derived earlier, we have learned an expression like this, which is similar to y is equal to mx plus c. And when you plot the rate data in this way, we get a straight line having a particular slope. And this represents first order uh, reaction. And if you plot it, the ratio of the concentration terms against time, it passes through zero. Both the diagrams represent first order. So many times we get questions having such diagrams, and we need to predict or find out or infer which is the order of the reaction. Therefore, it has to be carefully understood and kept in mind. Now let us take up first order reaction. A very important term is half-life period of the first order reaction. We can very easily find out K, or we can find out the half-life period in a first order reaction using the final equation that T half is equal to 0.693 upon K. And how did we get it? Here is a simple calculation or mathematical simplification. We know the relation is K is equal to 2.303 by T log R naught upon R, initial concentration and the concentration at time T. At T half, the concentration will be R naught by 2. Half का मतलब हो गया, आधा हो गया. And when we put up the values here and calculate the value of line log 2, you get this expression, that 0.693 upon K. So that's there, that's T half. अब ये टी हाफ से हमें बड़ी आसानी से पता लग जाता है कि ये किस टाइप का रिएक्शन है, व्हाट इज द ऑर्डर ऑफ द रिएक्शन. सिंपली डिवाइड के बाई 0.693. अगर के मालूम है तो हम टी हाफ निकाल लेंगे, टी हाफ मालूम है तो के निकालेंगे. दिस इज एन इंपॉर्टेंट कैरेक्टरिस्टिक ऑफ द फर्स्ट ऑर्डर रिएक्शन. इसको याद रखना पड़ेगा. एंड नेक्स्ट we have to take up certain questions right now. The first question which is here is quite simple, and the rate constant for the first order composition of C4H8, that is cyclobutane, into C2H4 at 500 degrees Celsius is given here, and we have asked that what time will be required for 80% sample to decompose. Simply, we have to substitute the values as represented here, and you get the answer as 1.7 into 10 to the power 2 seconds. Now let us take up another important. Now let us have one more question. And the question is quite important. It has appeared for many competitive examinations, including the CBSE examination. The question is, in a first order reaction, the concentration of the reactant decreases from 0.8 molar to 0.4 m in 15 minutes. The time taken for the concentration to change from 0.1 m to 0.025 m is, 4 options are given, and we have to find out the correct answer. So for solving this question, it's quite easy to solve. You have to find out the value of k with the data given, and then this k has to be substituted in same manner in the other case, that is 0.1 m to 0.0251. And here is the solution. If you find here, k is 0.04622, and finally when it is substituted, you get the value of t as 30 minutes. So the correct answer here is 30 minutes. That's the right answer. Okay, thank you. I suppose you must have got the concepts about kinetic. You must have got about the concepts about chemical kinetics part 3, that is integrated rate law, and also the first order reaction. Please review it a few more times so that you get the clear concept about the topics, and we should be in a position to solve different questions relating to chemical kinetics, first order reaction. Okay, please do subscribe. Thank you very much. Thank you. I suppose you must have got the concepts about chemical kinetics part 3, that is integrated rate law, and also the first order reaction. Please review it a few more times so that you get the clear concept about the topics, and we should be in a position to solve different questions relating to chemical kinetics, first order reaction. Okay, please do subscribe. Thank you very much.